Welcome to the Introduction to Multiplication. Today, we're going to talk about strategies that you can use to represent multiplication. Did you know that you're already a pro at doing multiplication and you didn't even know it? Think about times where you have skip counted to total up a number of objects you and your friends had. It could be markers, erasers, tacos at lunch, or even shoes. The fact that you counted groups of the same amount of something meant that you were recognizing equal groups, the first step in multiplying. Today, we have a few goals to get through. We're going to discuss three big things. The first thing we're going to discuss is what multiplication means to you and the rest of the world. Secondly, we're going to discuss ways to represent multiplication situations, such as repeated addition, arrays, groups, and objects. And last, we're going to talk about what the commutative property of multiplication is and what it means to you and in our world of multiplication. At the end, you are going to practice and apply these concepts by completing a practice page with your mentor and then completing the real-world project by yourself. Let's get started. Let's start with a little thinking. Meet Mike. Mike loves to take his two dogs for a walk in the park. How many people are walking their dogs in this picture? Just one, Mike. How many dogs does Mike walk? Two. When Mike arrives at the park, he meets two more dog owners walking their dogs. How many dogs are there in the park? Well, let's consider two questions before moving on. How many people are walking their dogs? And how many dogs is each person walking? You might want to pause here just to take a little time to discuss with your mentor and count up in the picture. Did you say three people? Mike's trip to the park shows us that there are three dog owners walking two dogs each. How many dogs are in the park altogether? Well, I see two dogs plus two dogs plus two dogs, meaning Mike has two dogs, the little girl has two dogs, and the man has two dogs, which means there are 6 dogs altogether. The park has 6 dogs in it. You'll realize that when we multiply, we end up using equal groups, just like the groups of dogs that each of these dog owners has. So what should multiplication mean to you? When we look at the word multiplication, we see a familiar word. Multiply. It means to get bigger in number or quantity. So when we talk about multiplication, we're talking about the operation that causes numbers or quantities to become bigger or increase. So let's talk about the big rule before moving on. Multiplication cannot happen if the groups you are working with are not equal. Otherwise, you're just adding different amounts of objects, and there is no reason for you to learn multiplication. So let's take a look at the first set of dog owners. We're going to think about Mike again. If he met up with other dog owners that had different amounts of dogs, we would have had to add those amounts together. 2 dogs for Mike, 1 dog for the little girl, and 1 dog for the man. Well, I can't multiply here because the groups aren't equal. It's not going to happen. But we can use multiplication in our second set of pictures because the owners had 2 dogs and we saw that amount of dogs 3 times, meaning Mike had a set of 2 dogs, the little girl had a set of 2 dogs, and the man had a set of 2 dogs. We can multiply here because each dog owner has the same amount of dogs. So how do I represent multiplication situations? There's 3 big ways that we're going to discuss. The first one is repeated addition. The second is arrays, and the third is groups and objects. Before we move on, let me give you a few hints. If at any point anything is confusing or you want to try to work on it with your mentor, pause the screen, take a minute, and feel free to go back. If you already know a concept, feel free to skip ahead a little bit. Always make sure that your work area is ready and clean. I'll give you hints along the way as to what you should have ready and prepared. Let's talk about repeated addition. When we repeat something, it means that we're doing the same thing over and over again. In repeated addition, we are using addition over and over again to find a total number of objects. Repeated addition can only be used when you're adding the same number many times. So if your groups are not equal, you can't do repeated addition. When we look at the park, we see that each owner has 2 dogs. We can use repeated addition to find out how many dogs are in the park because each owner has the same amount of dogs. You'll notice that we put a number 2 underneath each dog walker. Mike has 2 dogs, the little girl has 2 dogs, and the man has 2 dogs. We can call this repeated addition because we're repeating the same number, 2, over and over again 3 times. In the end, we add them together and we get a total of 6 dogs. So try it out. Pause your video and work with your mentor. Decide if each situation below can be solved using repeated addition. Make sure you're able to explain why or why not. You don't have to solve the problems, but if you would like to try, go for it. We will check our answers on the next slide. Take as much time as you need. Just remember to hit play to go on to check your answers. Let's check it out. Number 1, no way we can't use repeated addition. Each friend had a different amount of balloons. Remember, you can only use repeated addition if you are adding the same number repeatedly. Number 2, yes we can. Each cat has the same amount of treats in the bowl. We are adding the same number, 4, over and over again. Number 3, yes. Each cookie has the same number of sprinkles, 5. We are adding 5 sprinkles 5 times, representing the 5 cookies. Did you get it all? If you need to take a second, pause the video, go back and discuss with your mentor. How did you do? Were you able to figure out if each problem had repeated addition in it? Our next stop is arrays. An array is a picture representing objects organized into neat rows and columns. Each row or column has the same number of objects in it. An array can be represented using counters or other objects. You do not have to use the exact object you are talking about to show an array. Usually, people use counters. They'll use something smaller from around the house. Sometimes people use paper clips. The point of an array is to be able to show a picture representing a multiplication fact. It's easier to understand and it's easier to see. So let's talk about our dog walking problem again. Below, you'll see an array that represents the dog walking problem from the beginning of our video. This array has 3 rows, representing each of the 3 dog owners. There are 2 counters in each row, representing the 2 dogs owned by each person. The top row represents Mike and his 2 dogs. The middle row represents the little girl and her 2 dogs. And the bottom row represents the man and his 2 dogs. We would say there are 3 rows with 2 objects in each row. Let's try this one together. For this next part, you'll need about 20 paper counters. You can find them on your project tools page. About 20 small household items, such as pennies, magnets, etc. Pause here to get yourself set up. If you would prefer to use one or the other, just pick one. If you'd like to have options and you'd like to try the counters and a small household item, that's fine too. Play the video again when you're ready to move on. First, work with your mentor to make sure your work area looks like the work area on your screen. Pause your video for a discussion time. When you hear me tell you to pause again, that's when you can hit pause and work with your mentor. We're going to discuss the following questions. We'll catch up on the next slide. Number 1, what do you notice about the organization of the counters? Number 2, how many rows do you see? Number 3, how many counters are in each row? And number 4, what might this look like as repeated addition? How about multiplication? That's the challenge. Pause here, discuss with your mentor. See you on the next slide. I hope you guys had a great time talking. Let's catch up. Our first question was, what did you notice about the organization of the counters? I'm sure your answer doesn't exactly match what we had to say, but here are some of our thoughts. Arrays must be neat and organized. You can see that each counter is lined up with the one that is above, below, and next door. It makes it easier to relate this picture to multiplication. So as we move on, one of the big things you need to remember is that your arrays have to be neat. We can't have counters floating all over the place. We want it to be organized so that we can represent a fact using a picture. Number 2, how many rows do you see? You need to remember that rows are horizontal, meaning going across from left to right. If you were to look going across from left to right, horizontally, you would see 3 rows. How many counters are in each row? As you looked across from left to right, you should have been counting each of the counters or the circles that you see. Each row has 5 counters, including the counter that begins the row. Many times, the beginning counter is forgotten because it is thought of as just being the starting point. Don't forget about him. It's going to be really sad. Let's see what this would look like if we made it into a repeated addition sentence. We're going to lay out 3 spots. Each of those spots represents the 3 rows of counters. We leave a spot after the equal sign because we want to know how many counters we used in all. Since the first row had 5 counters in it, I'm going to put a 5 in that space. The second row had 5 counters as well, so I'm going to put a 5 there too. The third row had 5 counters, so I'm going to put a 5 there too. When I add up 5 plus 5 plus 5, or even do a little skip counting, I end up getting a total of 15 counters. Let's try to set it up as a multiplication sentence now. I leave 2 spots open. The first spot is for the number of rows, and the second spot is for the number of objects in each row. Of course, after the equal sign, I put the total. We know that this array has 3 rows. Let's put a 3 there. We know that there are 5 counters in each row. We'll put a 5 there. We have 3 rows with 5 counters in each row. We do 3 times 5, and we get a total of 15 counters. Let's compare it to our repeated addition sentence. 3 rows, meaning the 3 spaces that we have. 5 objects in each row. We put a 5 in each of those spots. In one, we add them together. In the other, we multiply. You might want to pause here and go through those slides just one more time with your mentor. Ask any questions that you have. If you want to watch it again, go for it. You're more than welcome to work along with the video in any point. It's time for you and your mentor to try it out. Pause your video and work with your mentor. Using counters to help you, build each array. Then, write down how you would represent each one using repeated addition and multiplication. This might be a good place to go back and review the video that we just watched. We will check your answers on the next slide. Stay paused so you give yourself plenty of time to work and discuss with your mentor. You can access a recording sheet through the Project Tools page or just make your own. How'd you do? I hope you had a good discussion. Take a look at number 1. 2 plus 2 plus 2 plus 2 plus 2 equals 10. I had 5 rows, 2 in each row, and that gave me a total of 10, which means that I have 5 times 2 equals 10. Let's take a look at number 2. 3 plus 3 plus 3 plus 3 plus 3 plus 3 equals 18. 6 rows times 3 in each row equals 18. Number 3. 4 plus 4 plus 4 plus 4 plus 4 equals 20. I had 5 rows with 4 in each row. 5 times 4 gives me 20. So what happens if we do this? As you can see, I have an array on the left, but then I have an array that's turned around on the right. Same array, I just turned it. Pause here. With your mentor, discuss what you noticed has changed from the first array to the second. Discuss anything that you think stayed the same. Unpause when you're ready. Welcome back. So let's talk about what's different. The second array has 3 rows with 6 counters in each row. This is different from the first array because that one had 6 rows with 3 counters in each. But there's a really big similarity. The total number of counters in the array did not change. If you counted them up, you'd realize that the left one has 18 counters and the right one has 18 counters. What does this mean? We call this the commutative property. This mathematical property or rule means if you switch the number of rows with the number of objects in each row, the total number of objects in the array will stay the same. In the first array, we had a total of 6 rows. We had 3 in each row. But when we made the second array, we switched the 6 rows with the 3. And we switched the 3 in each row with the 6. This property works because you're not adding any counters or taking any out, even though you're switching what each number in the multiplication sentence represents. In the first array, 6 rows times 3 counters in each row equals 18. In the second one, 3 rows times 6 counters in each row equals 18 counters. So let's try it out. Pause your video and work with your mentor. Use your knowledge of the commutative property to write 2 multiplication sentences to represent each pair of arrays. Discuss what changed from the first array to the second array. You will check your answers on the next slide. Build the arrays in your workplace if you would like. Just remember, the commutative property tells us that you're not adding any counters in and you're not taking any out. So keep that in mind as you talk and discuss about each of these arrays. See you in the next slide. Welcome back. Hope your discussion was good. Let's take a look at the first array. On the left side, we had 5 times 2 equals 10. 5 rows of 2 counters, 10 counters in all. In the second array, we had 2 times 5 equals 10. 2 rows of 5 counters, 10 counters in all. The placement of each of the numbers, the 2 and the 5, changed from each array, but each of the arrays had 10 counters. Let's look at the yellow arrays. On the left, you have 5 times 4 equals 20. 5 rows of 4 counters, 20 counters in all. On the right-hand side, you have 4 times 5 equals 20. 4 rows of 5 counters, 20 counters in all. Just like the other array, the 5 and the 4 switch places, but the 20 stays the same. We did not add any counters in, and we did not take any out. Great job! Let's move on to groups and objects. We can also represent multiplication by creating groups with objects. Pause your video and discuss with your mentor how the following pictures are different and similar. Look at the picture on the left, the array, and then look at the brand new picture on the right. Take your time. If you have to go back at all, please do. See you on the next slide. The picture on the left shows 10 counters arranged in 5 rows, with 2 counters in each row. We learned that we call this an array. The picture on the right shows 10 counters in 5 groups, with 2 counters in each group. Both pictures show 10 counters. They just happen to look a little different. We're going to try this together. For this activity, you'll need 15 counters or household items, whichever you prefer, a piece of blank paper with a pencil, or a whiteboard with a dry erase marker, if paper is not available or if you prefer this way. Pause the video and get set up. Today, our counters will represent apples in this activity. 7 friends went apple picking one weekend in September. We're going to represent each friend with a circle on our paper. You can pause to set this up after we see the circles. Make your paper look like our screen. The 7 friends went apple picking that one weekend in September, and each friend picked 2 apples from the trees. We will represent the apples using counters. We will place 2 in each group. You have your circles drawn on your paper. Take your counters and put 2 in each of the circles. Friend 1, friend 2, friend 3, friend 4, friend 5, friend 6, and friend 7. Pause and take a second to set it up. How many apples did the friends pick all together? Pause here and work with your mentor. Try repeated addition or multiplication to solve. Instead of thinking of rows and objects in each rows, replace the rows with the groups. Pause here and we'll see you on the next screen. Welcome back. Repeated addition would look something like this. I have 7 groups, and I have 2 in each group, meaning 7 friends and 2 apples for each friend. 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2. And when I add all of them up, I get a total of 14 apples. Remember, we can call this repeated addition because we're adding the same number of apples each time. multiplication would look something like this. Like I said before, where we would typically include a number for rows in the first part of the equation, we're going to use that for groups. Rows and groups represent the same number in a multiplication problem. I have 7 groups, or friends, and I have 2 apples in each group. That means the first number I'm going to use is a 7. I'm going to multiply it by 2, and it's going to give me 14 apples. Now it's time for you to try it out with your mentor. Pause the video and work with your mentor. Draw groups and objects to represent each multiplication sentence given. Discuss how to represent each one with repeated addition. Remember, the first number in the multiplication sentence represents the groups. The second represents the number of objects in each group. We're going to check your answers on the next 2 slides. Good luck! So let's check it out. Do your groups match up? Do your objects match up? Were you able to do repeated addition? Feel free to pause the video here and go back and check your answers as much as you'd like. Take time to discuss with your mentor something that confused you, something that you thought you did really well. Be proud of all that you've accomplished so far. Let's recap for the day. Today, you learned some really big things. You learned how to define multiplication and what it meant to you. You learned 3 ways to represent multiplication, and you used all 3. Repeated addition, arrays, groups, and objects. You also figured out what the commutative property of multiplication was and how to use it, showing a multiplication sentence and an array. I'm so proud of everything that you've learned today. So what's next? It's time for you to practice and apply what you've learned. Please feel free to come back to this video at any point in time. Look at the whole thing again. Look at small pieces of it again. Use it as a tool for you to be a pro at multiplication. Your first step is going to be practicing with your mentor. Download the Concept 1 guided practice page. Complete the practice with your mentor. When you finish, click the guided practice answer key link on the Concept 1 student page to review your answers. When you finish checking your answers and discussing, it's all up to you. It's time for you to complete the It's All You real-world project on your own. This project is going to have you use the skills that you used today and apply it to create something from our world. When you complete the project, you and your mentor will review your work using the real-world project rubric. That can be downloaded from the Project Tools page. Please feel free to come back to this part of the presentation in case you're not sure where to go, where your resources are located, or what step is next. Thanks for working so hard. Keep it up. You're going to do a great job, and we'll see you in Concept 2.